Hey there. Today we're diving into something that's totally invisible but controls pretty much everything around us. It's the reason we can stand up, the secret behind an athlete's balance, and how massive buildings stay, well, standing. We're talking about the center of gravity.
So, what could a tightrope walker balancing high in the air possibly have in common with a low-slung racing car screaming around a track? It sounds kind of random, right? But the answer is everything. Both have absolutely mastered managing their center of gravity to stay incredibly stable.
So what is this thing? Well, to put it simply, the center of gravity is one single special point in any object where it's like all of its weight is concentrated. For you, it's roughly in the middle of your body around your core. It's the average location of all the weight that makes up an object.
Now, here's the cool part. For objects that have a nice, even shape and are made of the same stuff all the way through, what we call uniform objects, finding this point is a piece of cake. It's hiding in plain sight, right at its geometric center.
Think about it, a perfect ball or a cube. The center of gravity is smack dab in the middle. For a can of soda or any cylinder, it's halfway down that line running through its core. In a plain old ruler, you guessed it, right at the 50-centimeter mark. It's all perfectly predictable.
And this invisible point has a pretty neat party trick. It's the perfect balancing point for anything. You can actually try this right now. Go on, grab a pen or a pencil and try to balance it on your finger. You'll have to wiggle it around a bit, but that one sweet spot where it just sits there perfectly, you've found its center of gravity.
Okay, so balancing a pencil is fun, but why does any of this matter in the real world? Well, it all comes down to one hugely important word: stability. Understanding the center of gravity is literally the key to making sure things don't fall over.
And when it comes to stability, there are really two golden rules. Number one, get that center of gravity as low as possible. And number two, make the base of support as wide as you can. You can see this perfectly when you compare a racing car to a regular family car. The race car is practically scraping the ground and has a super wide stance. Why? For insane stability. Your family car, being taller and narrower, is just naturally a bit easier to tip.
So, if being stable is all about having a low center of gravity and a wide base, what happens when you start to push those limits? There's a very precise moment when something goes from being stable to being very, very unstable. We call that the tipping point.
And the rule for this is actually really simple to picture. Imagine a straight line dropping directly down from an object's center of gravity, like a little laser beam pointing at the floor. If that line lands inside the area of the object's base, it's stable. You're good. But the second that line creeps outside the base, it's going to topple.
Let's see this in action. Take a look at this bus. It's on a little bit of an incline, but it's fine. That vertical line we imagined, it's falling squarely between the wheels, which form its base of support. So no problem here. The bus is perfectly stable.
But watch this. As we make that slope steeper and steeper, the bus tilts more. And suddenly that line of gravity is now falling outside the wheels. And that's it. It has hit the tipping point. The bus is going over. It's this exact same principle that keeps a leaning tower from falling, or explains why a toddler wobbles so much when they're learning to walk.
Now, that all makes sense for a bus or a ruler. But what about weird, lumpy, irregular shapes, like, say, a random-shaped piece of wood? You can't just guess where the center is. But don't worry, there's a super simple and clever experiment you can do to find it.
Here's all you have to do. First, you hang your flat object, let's call it a lamina, from a pin so it can swing freely. Then, you hang a weighted string, called a plumb line, from that same pin and just trace the line it makes on your object. Step 1, done. Then, you just do the whole thing over again, but hang the object from a completely different point. Draw your second line.
And this is where the magic happens. The exact spot where those two lines you drew cross each other, that is the center of gravity. You've just found the perfect hidden balance point of a weird shape using just a pin and a string. Pretty cool, right?
So you see, from tightrope walkers to racing cars, from a bus on a hill to the pencil in your hand, this one unseen point is the secret. It's the key to balance, the key to stability. So now that you know how it works, the only real question is, what are you going to design with it?